parallel and perpendicular lines. Essential question. How does the slope help you determine whether lines are parallel, perpendicular, or neither? The important thing to know about parallel lines is that they're two lines that run right next to each other but never cross. Parallel lines have the same slope. Perpendicular lines intersect at a 90-degree angle. The slopes of perpendicular lines are flipped and changed. So the little saying we use with this lesson is parallel slopes stay the same, perpendicular flip and change. So the key to figuring out whether or not two lines are parallel or perpendicular is looking at their slopes. In front of you, you have a grid. And using this grid, we're going to figure out what the slopes would be for a line parallel and perpendicular to the given line. If I have a slope of 5, a line parallel to it is going to be the same. So the line parallel to a line with a slope of 5 is also going to be a 5. Perpendicular, if I flip and change, here's what that means. If I have 5, I can write 5 as a fraction, like 5 over 1. Flipping it means that I'm taking it and I'm taking its reciprocal. The reciprocal of 5 over 1, or the flip of 5 over 1, is 1 over 5. The change means that instead of it being a positive 5, it becomes a negative 5. So if I flip and change, I have to do the opposite reciprocal, which would be negative 1/5. Let's go to the next one. If I have a slope of negative 3, my parallel slope would be the same, so it would also be negative 3. My perpendicular, well, if I write negative 3 as a fraction, that's negative 3 over 1. So if I flip it and take the reciprocal, I'd have 1 over negative 3. But then I also have to change the sign, which means I have to get rid of that negative sign. So it would be a positive 1/3. If my slope is 1/2, the line parallel to it would also be 1/2. If I have 1/2 and I flip it, or take the reciprocal, it'd be 2 over 1, and I change the sign and make it the opposite, it'd be negative 2 over 1. Or you could think of that as negative 2. Negative 2/3, a line parallel to it would be the same, so it would also have a slope of negative 2/3. If I flip it and take the reciprocal, I'd have negative 3 over 2. But then remember, I also have to change the sign. The original one was positive, so my new slope has to be negative. If my slope is 1, a line parallel to it would have a slope of 1. A line perpendicular to it, well, 1 over 1 is how I'd write it as a fraction. If I flip it, it's still 1 over 1. My original is positive, I have to change the sign to negative. So negative 1 over 1 would be negative 1. Okay, and then if my line is parallel,
Craig Haas to the office, please. Craig Haas to the office.
a line parallel to 4/7 would be 4/7. If I flip it, it would become 7 over 4, and it would become negative. Determine whether the lines are parallel, perpendicular, or neither. We're going to do 2 things to figure out whether or not these are parallel, perpendicular, or neither. The first thing I'm going to do is graph them. They're both in slope-intercept form, which means they're ready to graph. If I graph this first one, negative 3x plus 1, I'm going to put the first dot on positive 1. Then I'm going to rise negative 3, run 1, rise negative 3, run 1. So that is my first line. My second line has a y-intercept of negative 2. My slope is 1/3. So rise 1, run 3, rise 1, run 3. Now it looks like these lines are intersecting. We know they're not parallel because they touch each other. But it's hard to know whether or not they're really perpendicular because it's hard to tell whether or not this is a 90 degree. It could be but we don't know for sure. The way we can figure that out is by looking at the slopes. The slope of negative 3x plus 1 is negative 3. The slope of 1/3 x minus 2 is 1/3. Now let's figure out if these are flipped and changed. Well, if I have negative 3, I could write that as a fraction like negative 3 over 1. If I flip it, I'd have 1 over negative 3, and if I change the sign, it would be a positive 1/3. Did my other equation have a positive 1/3 as the slope? Yep. So that automatically means they are perpendicular. If the slopes are flipped and changed, if they're opposite reciprocals, then that means they're perpendicular. So this slope and this slope are opposite reciprocals. Alright, for this one, they're both in slope-intercept form, so I can graph them again. Put my first dot at 3, rise negative 3, run 4, rise negative 3, run 4. Connect it with a line. And then put my first dot at negative 1, rise 2, run 1, rise 2, run 1. Again, these lines intersect, but it's hard to know whether or not they intersect at a right angle, a 90-degree angle. So the way I'm going to figure that out is by looking at my slopes. I have the slope of negative 3/4, and I have a slope of 2. So you have to ask yourself, are negative 3/4 and 2 over 1, or 2, flipped and changed? Well, if I flip and change negative 3/4, I get 4 over 3, which 4 over 3 is not the same as 2 over 1. So we know that they're not perpendicular, which means it's neither. This time we have two equations, but we can't graph them yet. They're not in slope-intercept form. The key to this is you cannot tell if lines are parallel or perpendicular if they're not in slope-intercept form. That has to be your first step. So no matter what, don't do anything with a problem. Don't write parallel, perpendicular, or neither until you know that they're in slope-intercept form. These are, this one on the left here is standard form. Standard form doesn't give you the slope. So in order to get y alone, I'm going to subtract 4x on both sides. Bring down the 6y. I always put the negative 4x first, and then plus 18. Then to get y alone, I'm going to divide by 6. 6's cancel, and I have y equals negative 4 over 6. That I can actually simplify into negative 2 over 3. So I'm going to put negative 2 over 3, x, 18 divided by 6 is 3. So there was the other half of my heart. Here is my equation. My slope is negative 2/3. Now I can graph that. So if I go to 3 on my y-axis, rise negative 2, run 3, rise negative 2, run 3. All right, my other equation is also not in slope-intercept form, so I'll draw my train tracks. This time I just have to get rid of the 3 to get y alone, so I can put a 3 underneath. If I do my heart, negative 2/3, that doesn't divide nicely, so leave it as a fraction. 6 over 3 is positive 2. My slope in this equation is negative 2/3. If I graph that, I put a dot on positive 2, rise negative 2, run 3, rise negative 2, run 3. These lines look like they could be parallel, but we have to look at their slopes to know for sure. The slope of this line was negative 2/3. The slope of this line is negative 2/3. The slopes are the same, so they are parallel. Parallel, perpendicular, or neither. This is a click and drag to figure out which sets of equations should go in which box. I'm going to start with my parallel column. I know that parallel slopes have to be the same, so this one is the easiest. I'm going to drag over all the ones that have the same slope. So the slope is 3, the slope is 3. They are the same. The other one that I see is the same is right here. This one has a slope of 6, a slope of 6, so those lines have to be parallel. Now the other ones that I'm left with aren't the same, so I have to figure out if they're parallel, perpendicular, or neither. If I have 1/5 and 5, they are flipped. But the only problem with putting it under perpendicular is that they're both positive. One of them would have to be negative in order to be perpendicular. Positive 1/5 and positive 5, they're flipped, 1/5 and 5/1. I shouldn't have an equal sign because they're not equal, but 1/5 and 5/1, they are flipped, but they are not changed. The signs aren't different. Okay, this next one, well, I've got a negative, I've got a positive, that's a good thing. I've got a 4 and a 1/4, that would be flipped and changed. We have one of them that's negative, one of them that's positive, and they're reciprocals. This one of them is negative, one of them is positive, which is good, but one of them would need to be 1/2 in order to be flipped and changed. They can't both be 2. Summary. The homework for this lesson is page 241, numbers 33 through 38.